Hey, this is Raki, and welcome to The Explainer. Today, we're diving straight into the deep end to secure your foundation for the AWS Certified Cloud Practitioner exam. We're tackling the absolute core module today, and guys, this makes up a massive 24% of your final score. So grab your notes, get comfortable, and let's build your AWS knowledge from the ground up.
Here's exactly how we're breaking it down today. First, cloud computing basics. Then, the NIST characteristics, deployment and service models, the AWS global infrastructure, the well-architected framework, and finally, we'll wrap up with a quick exam sprint to test what you've learned.
All right, Section 1, Cloud Computing Basics. Really, why even move to the cloud in the first place?
Well, just look at the sheer financial and operational contrast here. On the left, you've got the traditional on-premises model. Imagine a company dropping 30 lakhs up front just to buy 20 physical servers. And it doesn't stop there. They have to power them, cool them, and constantly manage hardware failures. And the real kicker? Even if they only use 5 of those servers for most of the year, they've still paid for all 20. It's wildly inefficient. Now look at the right side. Cloud computing is simply the on-demand delivery of IT resources over the internet. Zero upfront purchases. You just rent what you need, exactly when you need it, with pay-as-you-go pricing. And AWS handles all that physical infrastructure. Honestly, it's like the difference between buying a massive fleet of expensive cars versus just calling a taxi when you actually need a ride.
Moving on to Section 2, NIST characteristics. These are the 5 unbreakable rules of the cloud.
So the absolute most crucial concept here is our first characteristic, resource pooling. And this brilliantly illustrates how cloud providers actually manage to operate at such a massive scale. Think of it exactly like a modern apartment building. AWS shares its massive physical infrastructure among thousands of different customers, but, and this is key, your specific data and applications are completely isolated and secure. Everyone has their own private apartment with its own locks, but you all share the building's core foundation, the plumbing, and the electricity.
The remaining 4 characteristics really complete the picture. First, you've got on-demand self-service. This means you can provision an EC2 server instantly without ever having to call up AWS support. Second is broad network access, meaning you can get to your resources securely from your laptop, your phone, or via APIs. Third, rapid elasticity. This allows you to instantly dial your resources up or down within minutes, which is an absolute lifesaver for, say, a streaming app during a massive live sports event. And finally, measured service. This ensures you pay strictly for what you use. Think of it like paying for the exact execution time of a Lambda function, or just the specific gigabytes of data you're keeping in S3.
Okay, Section 3, Deployment Models. Let's look at how you actually use the cloud.
You essentially have 4 main deployment models to choose from. You can use a public cloud like AWS, where the infrastructure is entirely owned and operated by the provider. If you absolutely need total physical control, you might use a private cloud dedicated to your organization on premises. Then there's the hybrid cloud, which is a mix of both. Maybe you keep your highly sensitive customer data locked down in your local data center, but you run your web applications on AWS. And finally, a multi-cloud strategy involves using more than one provider, like maybe mixing AWS for your raw compute power with Azure for identity management.
Now, for the exam, you absolutely have to memorize this breakdown of service models. Pay close attention to how the responsibility shifts here. With Infrastructure as a Service, or IaaS, AWS provides the servers and the networking, but you're on the hook for managing the operating system and applications. Amazon EC2 is your textbook example here. Move one column over to Platform as a Service, or PaaS, and AWS takes on a lot more of the heavy lifting. They manage the infrastructure and the OS. You literally just bring your application code in your data. Think AWS Elastic Beanstalk. And finally, Software as a Service, SaaS, is a fully complete software product delivered over the internet. Think Salesforce, where you're simply using the application without managing a single piece of the underlying tech.
Let's jump to Section 4, Global Infrastructure. This is the physical layout of AWS.
At the very highest level, we have what's called a region. A region is simply a large, physical geographic area somewhere in the world, places like Mumbai, Northern Virginia, or Frankfurt. When you deploy an application, you don't just toss it into some generic floating cloud. You choose a very specific region, and you're making that choice based on 4 critical factors: minimizing latency for your users, adhering to strict local compliance and data laws, optimizing for cost, and making sure the specific AWS services you actually need are available there.
Now, if we zoom into one of those regions, we find availability zones, or AZs. Guys, this is an incredibly important concept. An AZ is one or more discrete, fully isolated data centers right within a region. They have independent power grids, independent cooling, and independent physical networking. Why does that matter? Because if a flood or a massive power failure takes out one data center, the other AZs in that exact same region remain perfectly untouched. Deploying your stuff across multiple AZs is the absolute key to keeping your applications highly available.
Zooming in even further, directly to the end users, AWS utilizes local zones and edge locations. Local zones extend AWS services much closer to large population centers. That's absolutely crucial for applications demanding ultra-low latency. We're talking multiplayer gaming or live media streaming. Edge locations, on the other hand, act as little mini data centers strategically placed all over the globe, specifically designed to rapidly cache content. Services like Amazon CloudFront use these edge locations to deliver your website's images and videos to users in milliseconds, regardless of where your main server is actually sitting.
Next up, Section 5, the well-architected framework and its 6 pillars.
So the AWS well-architected framework is basically the ultimate rulebook. It dictates that your workloads must be designed around these 6 core pillars. You need operational excellence to run and monitor your systems effectively. Security obviously is paramount to protect your information. Reliability ensures your workload actually does what it's supposed to do consistently. Performance efficiency means you're using your computing resources smartly. Cost optimization ensures you aren't burning cash on unnecessary expenses. And finally, sustainability focuses on minimizing the environmental impacts of running your cloud workloads. You really want to keep these 6 pillars in mind because they inform quite literally every best practice in AWS.
All right, Section 6, the exam sprint. Let's look at some actual test day scenarios.
Now listen up, because the exam will actively try to trick you by mixing these specific terms up. Let's lock in the differences right now. Elasticity is specifically about automatically adjusting your resources up or down, precisely matching demand spikes. Scalability is a bit different. That's about increasing capacity to support longer-term growth, usually by adding more servers horizontally. High availability means your application stays accessible even if a component fails, which you usually achieve by using multiple AZs. Fault tolerance takes that a step further. It means absolutely zero interruption despite a failure, relying on extreme redundancy. And agility. That just refers to how fast you can provision and experiment with resources without waiting weeks for physical hardware to ship.
Okay, let's test this knowledge right now with a classic scenario you are highly likely to see on the exam. Imagine a retailer who normally operates with a small fleet of servers, but they suddenly need a massive amount of extra compute power exclusively during their short holiday sales event. What specific cloud benefit are they utilizing here?
If you said elasticity, you hit the nail right on the head. The key word here is only during holiday sales. The environment is automatically expanding to handle that massive rush of holiday shoppers, and then, crucially, it's shrinking back down just like a rubber band when the sale's over. This saves the retailer a ton of money compared to the old traditional on-premises model.
Let's try one more scenario. Say your boss comes to you and says an application is incredibly mission-critical. It absolutely must remain fully available to customers even if a single data center suffers a complete physical failure, like a massive fire or a citywide power outage. What's the architectural solution to this problem?
The correct architectural answer is a multi-AZ deployment. By actively spreading your application out across multiple isolated availability zones within a region, you guarantee high availability. If AZ-A catches fire and goes down, your traffic is just seamlessly routed over to the healthy servers sitting securely in AZ-B.
Well, by understanding everything from resource pooling and service models all the way down to the global infrastructure and the well-architected framework, you now officially possess the foundational blueprint of AWS. So, my final question to you is this. Now that you know the rules of the cloud, are you ready to take this theoretical knowledge and actually build your first highly available elastic architecture in the real world? Keep studying, keep building, and I'll catch you in the next explainer.